Next up, we have Dr. Joel Sherrill of OAR presenting on the RTEMS State of the Solar System. OAR and Joel are another very long-time sponsor of the Flight Software Workshop, and we thank them for their continued support year after year. Joel, it is over to you, and I believe we should have the webinar bringing up the slides. Yep. And Joel, do we have you?
I think we did. Hopefully I'm here. So
yep.
Every year I'd like to look back on what kind of, not as much what's going on in the project as, well, if you want to flip, we can get off the title slide. I kind of like to look back and see what all the missions have been doing. So this year there's a lot going on. Some of the missions have been going on a long time. Fermi and MMS. So Parker Solar Probe wins the award for being the mission I think I've seen in the science news the most. But DART certainly wins with the most Bruce Willis Armageddon references. So there's a lot been going on. Some of these missions have surprisingly long times, I think. So next slide. So it's thanks to you guys that RTEMS is as successful as it is. So I'm just going to highlight some things that it's likely, even if you watch the mailing list every day, that you may not have caught on to. And that's the main point of this presentation every year. And then to mention some things that are still going on and some things that, you know, we'd like to have some help with. So next slide. There's always a lot that's happened in the past year that doesn't meet the threshold for in this year-end wrap-up kind of thing. The big news, and there are two other presentations this week on it, so it only gets one slide from me, is that the ESA ECCS pre-qualification project has reached a major milestone. They have a continuous integration set up that builds qualification data packages for the GR712RC and the GR740 based on a subset of RTEMS based on, which is the SMP space profile that's been discussed a few times here over the year. One of the things that changed from an RTEMS perspective is that there are now requirements and specifications in an RTEMS central repository, and tests and some header files and some other supporting information is generated. So if you clone that repository, you can actually, there's a Python script that'll let you see which APIs are in the subset. So if you would like to contribute or see how much of this is covered by your project. So the challenge from my perspective, looking at it from the RTEMS project, is that we want to make sure that the central repository grows and expands and doesn't become out of sync. So the long-term viability for this is definitely up to the community. But there's two presentations later this week that should clarify that. One from somebody from ESA and somebody from the from Embedded Brains. But these are level C headed toward level B is my understanding. So hopefully we'll learn more later in the week. So next slide. So last year I talked about we were headed toward a point where you would be able, RTEMS itself would not properly, RTEMS properly would not include a network stack. So when you clone RTEMS and build it, there is no network stack now in the main repository. What we have done, in fact, is you now have 3 network stacks you can choose from after you build RTEMS, and you get exactly the same network header files, but you have a choice of the LibBSD stack, which is a port of recent FreeBSD, like FreeBSD 12 or 13, FreeBSD 12 at the moment, and is the recommended one. So it has a large set of device drivers, a large set of functionality, and it has the high performance, high end features that some systems need. The second stack we've got is we actually have an RTEMS LWIP repository, which we are integrating drivers. So one of the challenges with LWIP is that they don't distribute a lot of drivers with the stack. So this is going to be a port of LWIP to RTEMS with more drivers integrated, and it's available now. We did not delete the stack we have had for over 20 years. We moved it out into its own repository. So if that's the only option you have because you're on old hardware or whatever your rationale is, you can use it. So what we've left is it's a system integration choice, which TCP/IP stack, and we hope you lean toward LibBSD or LWIP in the future. Next stack. Next, next stack, next. So LibBSD, like I said, is FreeBSD. It's a port of a lot of FreeBSD code with very minimal changes. It's configured and tuned just like FreeBSD. So often you can just refer to the FreeBSD System Administration Handbook. There's lots of networking capabilities. Not up there is, that is up there, packet filtering. So you can do like bandwidth shaping or create a firewall with it. One of the big things this year was added was the NFS v4 client, which also brought along the support infrastructure for being able to, in the future, port FreeBSD file systems. There's a lot of code in here, a lot of functionality that's not just network, although that's where we started. You've got removable mass storage, NVMe storage support, SD card support, some graphics, some Wi-Fi. So there's a lot of code that's in there. Next slide. There's also commands. So when you're configuring this stack, you use this same commands and you just script them up at system startup if you're using it. Last summer, we gave a presentation to the EPICS workshop and to give a status on all the drivers they were using. So at this point, the only one of these that matters is that the Spark BSPs for the Leons right now is only supported in the legacy stack. So that needs to be, we need to get the LWIP driver or an LibBSD. But if you have some piece of hardware you're using that you're not sure about the status of and you think we should care, then please let us know. We built this off of the EPICS community. Next slide. Two big things happened over about the past 18 months. One is the AARC64, the 64-bit ARM port. OAR did the port initially for a customer to the Zinc MP, the MP SOC, the A53, and some other people in the community ported it to the Versal, the A72. So this supports the 64-bit native mode and the ILP 32-bit, which gives you a programming model similar to 32-bit ARM. SMP is supported. The BSP has support for almost all the peripherals on that SoC, including I2C, SPI, UARTs timers, and interrupts. It's got the network stack. It has SD card support. It has remote debugging support over network. And because of the debugging and the support for ADA, when you get exceptions, you can actually, they're recoverable and they can be propagated into the programming environment. So, and the customer was actually doing some ADA programming, so Gnat Pro is fully supported on this thanks to ADA Core. Next slide. And I can no longer pick on Alan or any of the guys at Goddard. The MicroBlaze port actually is well underway and almost should be finished up in the next month or two. This is only a single core port because I don't think the MicroBlaze has any multi-core support. It works on hardware and QEMU. It supports the basic things. It supports LibBSD and LWIP. Remote debugging and the NOR and the GPIO are still under development. I think the GPIO is done. There is a triple modular redundant version of the MicroBlaze, and if somebody is interested in that, we'd be happy to make that work, although it wasn't in our original requirements. So next slide. Out of the blue, someone in the past year actually popped up, started asking questions, and had supported MicroROS to RTEMS. MicroROS actually required very few modifications. I helped him test on a QEMU Zinc, so he had networking support. And although it's listed there as an issue, his issue write-up is very detailed, and it includes all the instructions needed to build and run RTEMS on run ROS on RTEMS. He also ended up porting the eProsima Micro XRC GDS client, and again, no real challenges except he just had to learn how to test on QEMU. I think was his big challenge, but it's there. It had been on the wish list a long time, and I thought this community might be interested. So if you want to play with it, it's there. Next. Another kind of invisible thing in the background, the OAR has put a lot of work into trying to get weekly build sweeps for RTEMS 5, 6, and 7. on the host environments that are popular in the community. So we actually have bought a fairly large machine, have a lot of VMs on it, and run weekly tests based on what's changed. So if the tooling changed, or if the RTEM source builder of anything it had changed, or RTEMS changed, it will actually go out and build all the tools, all the RTEMS BSPs. It will build and test every BSP which runs on a simulator, which is on the order of 24 or so. And then it will turn around, and if the BSP supports SMP, it will test with and without SMP. I was doing this on just CentOS 7. It took about 19 hours on an 8-core machine. The plan is to add Mingwin and Sigwin. One of the nice things here on the tail end there is Mac OS, which turns out a user pointed us to a way to create a VM for. So if you're interested in any host platforms or have experience, helping run down and odd failures is really appreciated, because we're just trying to make sure we get results frequently and get them posted to the community. Next slide. The other thing we're doing internally, which is very important, is RTEMS is a member of the Coverity scan program, and that gives us access to the Coverity tooling. So we're allowed to make 3 runs a day. So 3 times a day, a server at OAR checks if RTEMS itself, RTEMS tools, or the C library new lib changed, and then a build is done with Coverity and updates are done. And there's a couple of us who watch the reports out of this. If something gets worse, we'll poke whoever just committed something. Next. There's a new thing, Codiga. I think that's how you say it. This is another static analysis tool. I need to give a shout out to Julian Delange, who used to show up at this when he was in the flight software community. This is a little different. The Coverity scan, the way it works, it needs to work on a build of the software. So we only test for the Spark Leon configuration. This analyzes all BSPs and device drivers. So it covers RTEMS, RTEMS tools, etc. It runs via GitHub, and it covers everything: C, C++, Python, YAML. Gives RTEMS a real high quality score, but again, all of these tools, the challenge with them is that they produce reports that somebody has to look at. So we haven't looked. There've been some of these that have been looked at and fixed, but not a lot. Next. I mean, obviously, anytime we say something like that, help is appreciated. Try every year to point out what the activity looks like. The development list is where discussions about where RTEMS is headed, development activities are posted, and you can see that it generally hovers between 200 and 400 messages a month. That spike, I think, was a surge in some large patch submissions from the qualification project. The users list has a lower volume. Does get answered, but mostly most of the development, the activities on the development mailing list, and now on Discord. So I suspect that drop off in the end of 2021 coincides with us having a Discord server. Next. The build results, are holding steady on the 400 to 500 a month. The spike there, I suspect, when I looked back, I saw a lot of where everybody was setting up automated tests. So tended to be like every build failed, and you would get a couple hundred emails that all said fail, but they were all internal build failures. So to build these and keep this going, obviously, is a lot of server time and paying a list, but you have to pay attention to what's going on. Personally, I think all the core developers subscribe and filter out any email that says passed, because that's more. The version control list, every time a commit is made, a email is sent to this mailing list. So again, it varies by time period. If you look back, you can see people tend to take vacations in Europe in August, but mostly it hovers around 200 commits a month with spikes. Next. So officially, and although most people don't know it, we track architectures and BSPs internally and based on a tier. And we would like more to be at tier 1, which means we have results posted on real hardware, which means someone has run the test suite on real, got good results, can explain any failures and posted to build. The next tier is what gets done by a lot of the automated build systems, which is they're tested on simulators and posted to build. A significant number of BSPs fall into category 3, where you can only build it. And occasionally things fall into tier 4, where due to a bug, maybe it won't build for a while. The bigger reason something falls into 4 is when the tooling, if it turns out that the GNU tools are starting to age and the support is dropping, then this is usually a hint that the architecture is basically dying. So we had a couple, I think the M32C was the last one we killed because of that. So what we would like is to get the community, since you have more hardware than we do, it helped for people to submit results. Thanks to recent work at OAR and the ESA project, tier 1 architectures posted for these 5 architectures, which is probably no surprise to anybody. That's what people would expect to be tier 1. Next. So looking forward, what would we like to have? I mean, obviously we'd like the pre-qualification artifacts to expand. ESA did the heavy lifting on this first step. It'd be nice to see that expanded to cover what NASA might be interested in. We've had a long-standing wish for more code examples in the documentation. I think the challenge is actually thinking up what those are. There's always a need for BSPs for common and expensive development boards. I think someone's working on another round of STM board updates. The Wi-Fi support is an area for needs work, although I don't think it'll be used in a satellite. It needs work. I have to poke every so often about the RAD 750 BSP. It does exist, but it's inside NASA somewhere. Be nice to have BSPs for the newer BAE boards. Alan Cudmore probably can speak more to this, but it would be the Raspberry Pi 4 support could be improved, as well as the Pico. Long double support is not used very often, but the support needs to be improved for some architectures. NRC library. There is one of the things that happened was we transitioned away from the AutoConf automake build system to WAF, and part of that was to enable the use of other tool chains, including LLVM. LLVM has been used on 2 or 3 architectures, I think the Spark and the RISC-V, and it would be that's the Rust support. So we would like to see that, and we would like to see para-virtualization under SEL4. Next slide, please. So in the past few years, OAR has worked with DDCI to run RTEMS and ARINC 653 Apex applications side by side in a partitioned environment. So this was driven out of the requirements of the FACE technical standard. So we wanted to bring the history of DOS and the history of RTEMS and the capabilities together in one environment. So this gives you a time and spaced environment that you can run your RTEMS applications in. Next. So the FACE technical standard was started by Army and Navy Aviation to provide a standard operational environment so that software could be moved and shared. This ended up including 4 POSIX profiles, and RTEMS has officially now has been evaluated against 3 of these with DOS and meets those. It meets security, safety-based, and safety extended. The term we're supposed to use is aligned. Depending on the architecture, we are aligned with the general purpose profile, but the long double support on some architectures is missing. So that's what's driving some of the additions to the POSIX. There also is a new edition of POSIX coming out, which has some new methods. So, but the important thing is to make sure we meet all of these profiles from a POSIX perspective on as many architectures as possible. Next. So the cool thing here is that RTEMS is paravirtualized inside the address container on DOS. So you can run POSIX applications besides an Apex ARINC 653. And so we run as a guest. All the services are there, although it's including the classic API. Things port, software has been ported, fairly large software packages have been ported, and applications have been ported. So the idea here is that you can you have RTEMS in a time and space environment next to your ARINC 653 services, and you can use all of the interprocess communication mechanisms to communicate between the RTEMS partition and the Apex partitions. That includes ARINC 653 sampling ports, queuing ports, shared memory, and TCP/IP. So next. So the way this works is all of the RTEMS libraries and thread scheduling and support services were ported over, and they just run on top of an adapter on top of the DOS kernel. So we're paravirtualized, and it essentially acts like a BSP with some other support functionality, and you're running RTEMS. Next. So we've been through phase conformance process, I think 3 times now. We are now have been certified to be conformant to safety base and safety extended profiles of the latest edition of the phase technical standard. And we did that on ARM, PowerPC, and x86. So that should cover a fair number of avionics requirements. Next. So the project has been quite active. I was really happy when I started updating the slides from looking at what had been mentioned over the past few years. A lot of things we said were in process had actually been largely completed. It was also clear that the activities reflect user needs, the ESA qualification efforts, the 64-bit ARM port, and the MicroBlaze very precisely there because users wanted it. The pre-qualification effort is really exciting for the future. I hope that some of the NASA folks start looking at it and using it more. And we always could use help in improving our automation processes and knowing other things that would help you in your RTEMS deployments. So, you know, we're here, there are vendor sponsor kiosks sessions. There's a sponsor chat channel if you want to just ask us questions, but we also answer email too. So that's all I've got today. So hopefully see some questions.
Yeah, Joel, looks like we have plenty of questions for you. So I'll get right into it. So first, what went into choosing Coverity and Codega? Have you looked at how they compare to free static analysis like Clang or other paid ones like Clockwork?
Well, okay, so we couldn't compile with Clang until we replaced the AutoConf AutoMake system. But at this point, from what I remember, it doesn't particularly find anything that none of the other tools find. We started with Coverity because they had the Coverity scan program for open source projects. And honestly, we were reached out to about Codega. So, I mean, they have programs to work with open source projects without requiring you to host it yourself. So they were both pretty easy to set up.
Okay. In which tier is the RISC-V architecture at the moment? Are there any plans to promote it to tier 1?
It's tier 2, and someone would have to just post results on a real hardware platform, which I don't. Yeah. I think our board is too small to run it. Or board won't automate. It doesn't have a bootloader, so you have to load executables by hand.
Okay. What network stack would you recommend for mission critical RTEMS applications?
It would depend on how you have to qualify and what your requirements are. If you're going to have to look at the source and analyze it, LWIP is enormously smaller than the LibBSD stack. But if you need functionality, you'll have to move over to the larger stack. I would not look at the legacy stack for a new deployment.
Okay. Next question, is there a timeline for RTEMS 6 release, and does that depend on the ESA qualification effort?
The timeline is as soon as all of their work is committed, we've been closing issues. So I think the ESA qualification work is the main thing to go to 6. The 64-bit ARM was also a blocker, but it's largely cleared out now. So I think all the 64-bit ARM work is largely done. So we're waiting on the ESA stuff to clear. And in fairness,
Okay.
submitted almost everything. It's just that last bit at the end where you have to merge a lot.
Okay. What's the point of maintaining so many board support packages if in real life projects there is always a custom board?
The board support packages, so yeah, we're probably generous in keeping some around and just compiling them. So I agree with the sentiment of that. But most people take a stock board and base their own design on it. So that's one of the reasons. But the other reason is RTEMS is just simply used in a lot of communities. So that list of network drivers I listed, that was things that we identified as in use by the EPICS community and the Spark on top of that. But none of those would be by anybody in this workshop. So there's just a lot of users, and we are generally pretty generous about holding on to BSPs as long as there's a user actively reporting that it works. So.
Okay. And next question, do you have any plans for C++ 14 or C++ 20 support?
Easy question. So we actually stay pretty current with GCC. So if you're using GCC, RTEMS 6, we should be on GCC 11 and we'll switch to GCC 12 for the release. That's one of the other things we're hoping to go on to is, so GCC, C++ 14 has been in GCC for a long time. So it should already be in almost anything anybody's using that's recent. And 20 or 2X is just whatever state GCC is in today. So I think we're tracking pretty closely to what's going to be the GCC 12 release. So.
Okay. And last question I think that we have time for, any plans for open power?
Oh, the PowerPC? If somebody's interested, yeah, but I mean, it's not on the list. Speaking of open projects, Google Summer of Code is coming up again. So if anybody's got any idea for projects they'd like to see, we'd like to know what, toss them our way, because that's how we get students to do things, is to have good ideas. So they don't have to be critical of the project. They just have to be things people are interested in.
Okay. Joel, thank you so much.